We're so happy to welcome our next guest speaker onto the dais. We have Mr. Ravi Kiran, CTO of QurHealth. He's a technologist and innovator with a remarkable 30-year track record in enterprise software development. He has a background in designing and developing cutting-edge products and solutions for mission-critical applications within the healthcare, BFSI, and FMCG sectors. His passion lies in leveraging software to tackle complex problems, always emphasizing scalability, security, and robustness. And more importantly, user-friendliness. Mr. Ravi Kiran has multiple patents in hardware, software, and medical AI. A very, very warm welcome to Mr. Ravi Kiran. Over to you, sir.
Hello, everybody. Thanks, Aravind. Thanks for laying the foundation. So I'll just explain a little about what my presentation is going to be. I'll first start with some basics. So because a lot of times what happens, people from other basically fields, a lot of terminology gets thrown around in AI, and we don't normally get it. So even before we go there, I'll start from the basics, and then somewhere along the middle, I'll get into the actual crux of the problem. So to start with, let me start with this. Why do we need AI, ML, deep neural networks? These are all things that people actually talk about a lot. So what had actually happened was, computers were great at solving deterministic problems. That is, whether something is on or off, binary, everybody knows that. There were a class of problems that started coming up which did not conform to this, which is basically perception. Like, how do you take human problems, which is perception based, which is never 0 or 1? Like, I want to just give an example. Like, for example, if you go to a computer and computer asks, how are you feeling? And your wife says, I'm perfectly all right. A computer will say, okay, and go on. But a human interaction is not like that. A perfectly all right need not mean perfectly all right. There'll be so many undertones to it, so many things to it. So something as simple as a basic interaction has so many complexities to it. So people started realizing that a simple language, computer-based language, computers-based traditional algorithms, which are deterministic algorithms, were not working for a class of problems. Most of those class of problems were to do with human perception, things like vision, things like speech recognition, things like speech understanding and things like that. So that is when a lot of mathematicians got together and figured, you know something, a computer does not actually simulate a human brain. So why don't we go around and try to figure out how a brain works and come up with an approximation of how a human brain or any animal brain works and try to simulate it on a computer and see if that works. So that became the foundation of a neuron, a neural network, or a perceptron. So what basically people have done is they've taken or think they know how the brain works, taken an approximation, and they simulate it on a brain. That became the foundation of almost all neural networks. So the first application of the neural network was in handwriting recognition, because till neural networks came along, handwriting recognition used to be an extremely complex problem for computers to solve, because my handwriting will be different from somebody else's handwriting. It's very easy for a computer to find a name, but for understanding handwriting, it used to be a problem. Just 20 years back, I remember, I don't know, I'm from that generation, we used to have Palm Pilot. A Palm Pilot used to be a PDA. So they actually had to come up with a new handwriting for actually recognizing this, because the traditional, the way we write ABCD, the computer was not able to recognize. So they came up with a different language. So the first solution actually was handwriting recognition. That's where the neural networks basically started being applied. So now, like, getting into a little more this, then the neural network started improving a little. So then you had what is called as a deep neural network. Deep neural network is, instead of just a couple of neurons, you organize neurons into multiple layers. So one of the things is multi-layer perceptron. So primarily it was used for data classification. Then you have convolutional neural networks. This is another breakthrough that happened of how you organize a neural network to do vision. I bet a lot of, probably 5 to 6 years back, a lot of companies came up with detecting cancer in breast cancer, basically X-rays, detecting cancer, brain cancer, and like all those things, like for example, detecting TB in lung scans. So all those models are actually convolutional neural network models, or they use one of those combinations. So image recognition is something that convolutional neural networks use. Then you have recurrent neural networks, which is primarily used for NLP tasks. And what had happened was in about 2016, an Indian who was working in Google Brain came up with a way to organize basically these deep neural networks, and he invented basically the transformer model. That has become the foundational model for all the revolutions that you are seeing now. So again, this is just for this. A lot of people use ML and AI interchangeably. So I basically wanted to just explain like, okay, how machine learning is different from artificial intelligence. In machine learning, what you basically do is you take a bunch of data, you tell the computer what the data is. You say, something, this is the region where the sale happened, this is the amount of sale happened, and this is the date. You go figure out the pattern. So the computer will go out and figure out and say that, something, in north, during winter months, this thing sells better. And in south, during this months, this sells better. I'm just talking about 3 parameters. This can be hundreds of parameters. This is machine learning. Machine learning is where the human tells the machine what is what and asks it to figure out the patterns. Basically, all along, we used to tell the pattern and ask the computer for what it wants. Basically, we used to tell it, does this match this condition, is how we traditionally do databases, querying, and things like that. In machine learning, what happened was we asked the computer to figure out the patterns. But the challenge there, again, was you need to know what the data is. With neural networks, basically AI, what you do is you don't tell anything. You just give the data to it and say that, something, you figure out what the data is, you figure out the correlation between the data, and you come back and tell me what is going to happen. So that is the primary difference between machine learning and AI, which is a lot of times people use it interchangeably, but there's these are completely 2 different areas, actually. And what actually you do in deep neural networks is you need loads and loads and loads of data. So one of the first image recognition model worked because there is a university grad student who sat and manually basically noted down what each and every image meant. So they created this huge data set of images with what each and every image meant, and then they trained the neural network, and then it was able to recognize the old, a lot of people know the cat versus dog computer detecting. That was basically built because people built a lot of data. And again, one of the important questions that people ask now is, AI has been around for a long time. Like it's been around for almost 30, 40 years. But why is it becoming so big now? What is so special now that everybody is talking about it? So what is the key breakthroughs that happened that made AI be the cool kid now? First was, in 2011, Google basically figured out that if you because deep neural networks and this technology has been around for about 30 years. One of the researchers in Google found out that the accuracy of neural networks improve when you throw computing at it. So if you give a lot of processing power to it, it becomes better. So Google actually had the money, actually had the backing, and this is the primary reason you see majority of the neural networks being built today are done by like multi-billion dollar organizations, and training those take millions of dollars. So the first, they took 16,000 computing cores, and they basically trained this model and found that it was way more accurate than what they had before. So that is when they realized, something, if you throw a lot of computation power at some problem, and you are able to parallelize the solution, you will be able to come up with this. So now, as Arvind mentioned, now people don't use traditional computing cores. We use NVIDIA's GPUs. GPUs are, each GPU, for example, if you buy a 3090 card, that has close to about 8,000 individual cores. So today, a desktop computer can actually have 8,000 cores. If you have 2 cards, you are almost matching like 20 years back, 10 years back, what Google had. So this is where the revolution has started happening. Now we have the processing power, and we have loads and loads of data that is there in the internet. Like 20 years back, before the internet came along, we didn't have data. Nobody digitized all the books. Google now has digitized almost all the books in the library. So every medical book ever written has been now digitized. So now you have loads and loads of medical data, social media data, and all these things. We have digitized that, and now we have trained the neural network. So Google also invented the transformer model in 2017. So now let's get into what a LLM is. LLM is nothing but a large language model that actually is trained on vast amounts of data. So to give you an analogy of how it happened, let's say we get a kid and we let him loose in a library. And the kid learns every single book in the library, so he is able to ingest all the information in the library. This is what the base model was. This is what people had. There were like a bunch of models that happened. What led to the breakthrough of ChatGPT was It was horrible. The kid could not communicate. Think about it. You let him loose in the library, but he didn't have a way to communicate with you. So then a bunch of engineers in OpenAI figured out, something, how about we train the kid to talk to us? So then the kid will be able to answer anything. So he has all the knowledge already. So that was the key breakthrough. What ChatGPT did was, it gave a chat interface to a large language model. So now all of a sudden, any one of us could go and ask a question, and with its knowledge, it's able to answer. So that was a fundamental breakthrough that happened, where they were able to basically take reinforcement learning through human feedback is how they improved the accuracy of it, and they provided basically a chat interface to it. That is what led to the fundamental breakthrough. So the fundamental thing that a LLM does is very, very stupid. If you actually think about it, it is no different than predicting the next word when you're typing something. So this already happens. If you open up your mobile phone, you look at the keyboard, you type the first few letters, it completes the word, right? Just imagine that, scale it 1 billion times. Now you have whole bunch of data. So you give, say, 100 words, it'll try to predict what the 101st word should be, 102nd word should be, based on the information it's already learned. So to give you an example, it already will have a data that the president of United States in 1994 was, say, Bill Clinton. So you say, who is the president of America at 1994. So because of it already has the data of Bill Clinton, it will predict that Bill Clinton is supposed to be the next word. So all a large language model does is predict what is going to come there. So it's not something that's intelligent. A lot of people think it's sentient, it's like intelligent. It's completely, if you go down to the technology, it is absolutely dumb. All it does is predict the next word from the corpus of data it has. So then people basically did fine-tuning and things like that. So where it started interesting, things started happening was, when they started making the models bigger and bigger, interesting emergent properties started coming in. So as I told, initially it was a very dumb model which was only able to predict the next word. Now new emergent properties started coming in. Things like, for example, when you increase the size of the model, it's able to do mathematics. Nobody imagined that a large language model can do mathematics. Like, we designed it to predict the next word. How is it able to predict what is 8 plus 8 is or 5 plus 5 is? So then they started realizing, something, we don't understand this. This is where the black box emergent properties of large language models come in. And this is where people are saying, once you start scaling up the language models bigger and bigger, it will start doing even more. So this is where majority of the innovation is now going in. And this is where people are all scared that if you scale it up large enough, it can become artificial general intelligence, where it will start doing things that even we didn't know what was happening. So now I'll just give you a basic of this. So ChatGPT is nothing but a large language model from OpenAI. There are large language models from other vendors also. Google has Palm. There are so many other things that's going to come in. So ChatGPT is the new kid in the block now, who's very popular now. It's the movie that's hit now. 6 months later, it'll be totally a different movie. It may be a totally different company. Like Palm is doing a lot of work. From a medical point of view, MedPalm is basically a large language model trained by Google on medical data. They're saying that is going to become extremely relevant for the medical industry. So that's going to be a great thing. So one of the primary challenges in any large language model is hallucination. As I mentioned, it actually got trained on this huge corpus of data. So it's just predicting what the next word is going to be. So if the data is wrong, the prediction is also going to be wrong, just as your garbage in, garbage out. So this is where the challenge is happening. Like, for example, if you ask a large language model, tell me this diagnosis, it might actually assume certain data that is not there in the data that you gave. Like, for example, you might have uploaded a PDF with, say, 20 different medical parameters. The outcome that it's going to come out with need not consider only those 20. It might have considered 3 or 4 more. This is something that you can practically check. For example, if you ask a large language model to write code, it will actually create APIs that are not there in AWS. So those kinds of things happen. So hallucination is a very, very critical problem that is there. We've still not solved it. This is the primary reason. There are a lot of disclaimers. As Arvind mentioned, you have to have disclaimers because you cannot be 100% sure of what a large language model generates. Second problem that large language models have is alignment. Alignment is, how do you know your large language model's output is what you also want? To give you a practical example, Say you have designed a large language model to help in critical scenarios. And a person basically types into ChatGPT that I would like to commit suicide. ChatGPT does not understand that's a bad thing. So it will come up with 20 ways you can kill yourself. That is not aligned to what humans are. Any human with the basic common sense knows if somebody comes and asks me, I'm going to kill myself, I should not say, give them options of 10 options of how to do it. But as far as it's concerned, it's helping you. It's helping you with your solution. So this is where the alignment problem comes in, where how you think what is your value system is not what the value system of a large language model is. This is another primary challenge that's happening. The third primary challenge is privacy. That is, when you give your data to one of these large language models, you absolutely have no clue of what it's going to be used for. Now, let's get into the critical things. So these are things that are primarily the use cases that we have found like this. One of the most important thing about ChatGPT or any large language model is it can be beautifully used for content generation where you are the domain expert. You are the domain expert, you know what is going to happen, and it can be a very beautiful co-pilot. It will come up with ideas, you filter out what is good, what is bad, and then you go on. The first thing that it can be used is, it can be used for copywriting, it can come up with marketing content, it can come up with website content. Like for example, all these things are something that we came up with. Like for example, we came up with, for a website, we just came up with about 2 or 3 lines of what the product should be. ChatGPT was able to automatically come up with the website content. It came up with the content for the website. It came with the mission, vision, product description, and all these things. So that way what happens is, if you have an idea for a product and you want to create a website, you can use content creation beautifully. The advantage here is, when it comes up with some garbage, you can always go back, look at it, fine tune it, you can regenerate it, and you can actually take what you want, what you don't want. And you can create full blog posts about any topic that you want. And then again, you are in the driving seat. So it's just a co-pilot. It's going to give you an option. You're going to pick and choose what you want. Second is business ideas. That is, you can take an application that you already have and ask ChatGPT where it can be applied. This is another interesting thing that happened. So for example, in one of the products that we had a product for doing real-time location. And we told this is a product that can be used for real-time location, and it can do task management and things like that. And ChatGPT was able to come up with a solution saying that, you know something, it can be used for allocating tasks based on proximity. That is a word that we never gave. We did not know. It came up with an idea saying that, you know something, because these 2 features are there, the third feature can automatically come up, which can be extremely useful because you might have a product, but you don't know the exact use cases of that product. You can ask the ChatGPT to give all the use cases for that product. Second is, you can create email content generation. You can have customized replies to a customer. You can create customized replies to insurance companies based on simple prompts. Like one of the primary use cases for this is people who are not good in grammar. In Chinese language, it seems a lot of people do that. Like you just say, your shipment delayed, send information to customer. So it will come up with a beautiful email saying that, dear customer so-and-so, we would like to apologize that your shipment XYZ got delayed for such and such reason. So it comes up with a beautiful email which is customized for everything. So you can take like one row of your data and come up with full-fledged emails. And you can create, again, this is another interesting thing you found. You give a description to ChatGPT and ask it to come up with PPT points. It automatically creates PPTs for your actual slides, and it can actually create and explain it video content also. The other day we took the entire page of a website and we told, okay, create an AI explainer video for this. So it basically came, okay, the first video slide should have this, second video slide should have this, third video slide should have this. So for content creation, it's extremely good. Second is you can create, for example, search engine optimization. This is another major challenge today. Say you have a beautiful website. You want to optimize your website with search engine. Today, you have to hire a consultant who will come in and tell, okay, these are the search engine keywords you have to use. ChatGPT will beautifully come up with those things. For medical things, you can come up with diet plans. This is another important thing. We actually had used this. Traditionally, if you want to create a diet plan for a particular disease condition, for example, you want to create a diet plan for a diabetic who's also vegan and who cannot eat carrots. Traditionally, you have to create it. It takes a lot of time and stuff like that. You can actually give those requirements to ChatGPT and create a diet plan for you. But again, you are basically, the dietitian still will be the main person who understands, who is the domain expert. And he'll basically use ChatGPT to create diet plans. So that way you can create customized diet plans for each and every patient. It can do question and answering. It can do job interview creation. This is another important use case that people have started using it. So if you want to create an interview questions for your, say you're going to hire somebody for like some radiology and stuff like that, it can actually create interview questions. It can create compliance checklists. This is another important thing. When you're going to go for like some sort of approval, ISO certification and things like that, you want a compliance checklist. So you can ask ChatGPT to come up with a compliance checklist for a particular compliance program. So that is something that you can do. You can create customer surveys. This is another important thing that you can do actually. So if you want to create a survey for your customers to do something, you can create that. And then content manipulation is another important thing that ChatGPT can do. It can actually summarize large articles and email threads, especially for doctors who actually have a lot of content that they have to deal with. Like for example, a patient basically comes and dumps, like how Arvind mentioned, that they come up with like a 30-page file with all historic records and stuff like that. You want to summarize it. This can beautifully summarize the content. Second is this is again more for marketing. It can actually create clickbait style descriptions from normal descriptions. Like for example, you might come up with a description, but that might not be marketing optimized. So it can actually optimize the content beautifully. These are things that traditionally copywriters used to charge a lot of money for. That is something that you can do. You can do rewriting the content, grammar checks and things like that. So for example, if you're developing a blog article, after you complete the blog article, give it to ChatGPT, ask it to rewrite it, it rewrite it in a totally different way. And you can basically personalize email with medical special contents and things like that. Another important thing that we found was, when you have loads and loads of data coming into your organization, it is very, very important to identify the sentiment of that. Is the customer yelling at me? Is the customer happy with me? And things like that. That traditionally is an extremely manual work. That can be automated in this. So what you can actually do is you can pass all the emails that you're getting, all the call center transcripts to an LLM, and it will tell you, okay, this is the overall sentiment of the people about your organization. And this many angry people came. This mail is angry. This mail is like congratulatory and things like that. So another important thing is you can create translation. Say, for example, on-the-fly translations of content you can create. So for people who are like in the organization and stuff like that. So you can also do triage on incoming tickets. Like for example, if you have a ticketing system and you want to make sure that only the critical tickets gets escalated to the right people. So you can actually do triage of all the tickets. You can do risk stratification. Like for example, if you have like say 20 or 30 different lab reports that are coming out every day, you want to highlight and you want to locate only those lab reports that actually have like some critical things in them. So those things you can automatically do, where it will be the first level checklist for you, so the doctors can automatically know. In almost every hospital has a lab today, and you'll have like hundreds of reports coming out. So it will automatically highlight, this patient has this problem, and this patient might have this problem, even before a doctor actually looks at it. And you can actually have a system that can answer any question about any topic, diseases, diagnosis, and things like that. Again, sometimes it will definitely hallucinate and come up with some random answer. That is where you become the domain expert and do the necessary checks and things like that. And this is more for the IT people here. So what can ChatGPT do for? It can develop, it can do code generation, it can do rewriting the code, it can do refactoring of the code. This is another interesting thing we found, that it can generate JSON from free text. Like for example, if the doctor types something in an extremely unstructured text, you can actually create a JSON out of it. This is something that in Kaveri Hospital we use it. So that way what happens is you can take the JSON and then populate a database into that. So that is something that you can do. It can detect bugs in your code. It can document your code. Another important thing is, like for example, you just come into some sort of somebody has written a bunch of code and you don't know what it's doing. You can give the code to ChatGPT and ask it to document. So it will tell you, okay, this is like an API call going here. This is what it's doing. So documentation it can do. It can generate SQLs, full-fledged SQLs with schema and requirements are specified. This is another thing. A lot of people want like some sort of reports to be generated automatically, complex reports to be generated. You can just give the schema to it and say what kind of an aggregate query you want. It can automatically generate that for you. So what are the next steps and the future for LLM? So primary challenge today with LLM is privacy. You don't want to give your private data, especially PHI, PII data, to a third party. So this is where huge amounts of innovation is happening, where private large language models are becoming available, open source large language models are becoming available. So you can actually take that and put it within your organization, or even like host it in AWS. So that way, this is the data you give to this large language model will not go out of your purview. You can hold it directly. Another important thing that's coming up is LangChain basically. So this is another interesting thing that's happening, is where, say you want ChatGPT to answer data on the database you already have. Like for example, you have a huge database of emails or huge database of your internal documents, and you want to chat with those documents. So that is when what you do is you take your documents, give it to a vector database, basically index the whole vector database, and give a question along with the vector database to a large language model. So the large language model uses the vector database information for context, and it uses basically a natural language understanding and prediction using the large language model. This is how you can query your data. You give a CSV, and you say, okay, tell me the best performing products in this CSV. Those kinds of things, you can do that. And you can also do data analysis on your transactional and EHR data. And the major thing that's again happening is large language models on the edge, where they are saying that maybe the next version of Apple iPhone and Google Pixel will have some sort of a neural module on the phone, so you can actually do large language models there. So that is where the future is going. Even more futuristic than that is, today the primary challenge with large language models is just the sheer amount of data and the cost required to train is ridiculous. So what people are trying to do is, can we train it using a different system altogether, which is first is use analog chips instead of digital chips. That is happening. Second is fusion of biologics and neurons with electronics. That's another thing that's happening, where they are taking a silicon chip and putting biological neurons onto it, so that instead of using simulating a neuron in software, you can actually use real full-fledged neuron is something that you can do. And second is using quantum computers again for optimizing DNNs. So that's my thing. So to give you an example, what is going to happen in the future at least is, this is the amount of news you are getting for large language models now is ridiculous. Every week, new breakthroughs are happening all the time, especially generative content, and those kinds of things are happening. A lot of things are happening. So where this is heading is ability for large language models to do even and more logical and reasoning-based tasks. When that happens, then you can be a lot more comfortable using large language models in these kinds of scenarios. First is, you have to take care of privacy, you have to take care of alignment, and once privacy and alignment is taken care of, then accuracy will automatically be the next thing that we actually have to go through. So thank you.